Alright, another one. Evaluate the integral. Integral 1 over 2 e to the power of x minus 3 dx. Now, this can give you a headache because if you want to make a substitution, 2 e to the power of x minus 3 equal to u, and when you take the differential, it will introduce another e to the power of x, but there is no e to the power of x on the numerator, so that is going to really confuse you. So what is the way to deal with it? There is a beautiful way we can make this into a workable form, and that is, you can multiply the numerator and denominator of a quantity like this with the same quantity. So if you multiply numerator and denominator by e to the power of negative x, it will become a beautiful integrable form. So here we have a problem. If we substitute 2e to the power of x minus 3 equal to u, then du will contain an e to the power of x. Try that and see. Which is not present on the numerator. If there is an e to the power of x on the numerator, we have no problem. We can make a substitution, this equal to u. But since we don't have an e to the power of x on the numerator, that is a serious problem. So we can change this situation by multiplying the numerator and denominator by e to the power of negative x. Alright, let's do that and see what happens. So multiply the numerator by e to the power of x and the denominator by e to the power of x. If you don't want it, you can just cancel them. But we want them because this is going to change our situation. Alright, tell me now, distribute that e to the power of negative x. You should know that e to the power of x multiplied by e to the power of x, e to the power of negative x times e to the power of x will be 1. Is that right? So the denominator now becomes e to the power of negative x times 2 e to the power of x is 2, and minus 3 times e to the power of negative x is minus 3 e to the power of negative x. So look at the denominator now when you multiply. It will be e to the power of negative x over 2 minus 3 e to the power of negative x. Now we have an e to the power of negative x on the numerator. Therefore, we can now substitute the denominator equal to u, because the e to the power of negative x that is going to come in du can now be accommodated. So we substitute 2 minus 3 e to the power of negative x equal to u. Alright, how do you take the differential? Differential of 2 is 0. And what is the differential of 3 e to the power of negative x? Now, leave that negative 3 alone. The differential of e to the power of negative x is e to the power of negative x times negative 1. So this will be negative 3 times negative 1 will become positive 3 e to the power of negative x dx. That's the differential of the left hand side. So 3 e to the power of negative x dx is the differential of the left hand side. Do that one more time. Check it again. Negative 3 times, find the differential of e to the negative x. It will be e to the negative x times negative 1. That negative 1 times negative 3 gives me positive 3. So positive 3 e to the negative x dx is the differential there, and differential of u is du. So once you have this quantity equal to u, now watch this. E to the negative x dx can now be replaced. E to the negative x dx can be replaced as du over 3. So this is our u, and e to the negative x dx becomes du over 3. So our integral now becomes integral 1 over u du over 3. So that is, this becomes du over 3. And so there is a 1 there, 1 over u du over 3. And we can take out that 1/3. So that will be 1/3 integral 1 over u du. Again, what is integral 1 over u du? Is ln of u plus c. So that's 1/3 ln u plus c. And replace your u. What's our u? 2 minus 3 e to the power of negative x. And as you did before, 1/3 ln of this quantity. What's the role of that 1/3? That 1/3 is actually the power of this quantity. And raised to the power of 1/3 becomes cube root. So that will be ln cube root of 2 minus 3 e to the power of negative x plus c is the result. You can see the way that you've got to see this, what to do there to make it a form which we can integrate is very important. All right, another one. Evaluate the integral. Integral 1 over secant x minus 1. This is again a form that is rather difficult because we cannot really find any integration formula we learned which will fit in here. So what we try to do is try and do some manipulation. We have a secant x minus 1 on the denominator. So why don't we try multiplying the numerator and denominator by secant x plus 1. Why? Because secant x minus 1 times secant x plus 1 is secant squared x minus 1. And secant squared x minus 1 can be simplified using one of the trigonometric identities. Is that right? All right. Now here again, direct substitution is not possible. So we need to do some manipulation. And the manipulation is multiply numerator and denominator by secant x plus 1. So this integral now become multiply numerator by secant x plus 1, the denominator by secant x plus 1. What does that become? The denominator becomes secant squared x minus 1. So the numerator is secant x plus 1. The denominator is secant squared x minus 1. What is secant squared x? If you remember our identities, 1 plus tan squared x equal to secant squared x. Therefore, secant squared x minus 1 is tan squared x. So we can replace, recall this, 1 plus tan squared x equal to secant squared x. Therefore, secant squared x minus 1 equal to tan squared x. Let's replace that. So that will be secant x plus 1 over tan squared x dx. That is the quantity for integration. And now the next thing we can try is try and split this into two pieces. You see, this can be written as secant x over tan squared x plus 1 over tan squared x. Is that right? Try that. So split this into two integrals, that are two terms. That would be integral secant x divided by tan squared x plus 1 over tan squared x dx. And then, again, using our knowledge of trigonometric identities, we will replace each of these. What is 1 over tan squared x? 1 over tan squared x is cotangent squared x. Alright. We have this is the integral we had earlier, so that will be integral secant x over tan squared x plus cot squared x. 1 over tan squared x is cotangent squared x. And we are now going to replace secant x as 1 over cos x, and tan squared x is sin squared x over cos squared x. So tan x is sin x over cos x. Let's try and replace that. So that will be secant x is 1 over cos x, and tan squared x is sin squared x over cos squared x plus cot squared x. And if you simplify that, what do you get? Well, we know that 1 plus cot squared x equal to cosecant squared x. Is that right? And therefore, cot squared x can be replaced as cot squared x is cosecant squared x minus 1. So let's do that. Replace this as cosecant squared x minus 1. Why? Because cosecant squared x is a form that you can integrate. Cot squared x is a form that you cannot integrate. So replace cot squared x as cosecant squared x minus 1. Well, when you simplify this, will you get this as cos x divided by sine squared x? Now remember, this is 1 over cos x divided by sine squared x over cos squared x. This cos squared x will go all the way to the numerator. And this cos x and 1 cos x will cancel, leaving on the numerator a cos x. So this will simplify as cos x over sine squared x plus cosecant squared x minus 1. Now look at the manipulation that we have to go through to make it in a form that we can integrate. We haven't finished yet. Well, now split this into two different integrals. Now the left one is integral cos x over sine squared x dx plus integral cosecant squared x minus 1 dx. Now this is something we can integrate. We know what is integral cosecant squared x is. Do you know? What is the derivative of cot x, cotangent x? Is negative cosecant squared x. Therefore, cosecant squared x can be integrated and minus 1 dx can be integrated. Well, if you look on the left, we can also integrate this by doing a simple substitution. What substitution? We can put sine x equal to u. Then cos x dx will become du. You see how simple it is. So to evaluate the first integral, we substitute sine x equal to u. The sine x become u. Take the differential of both sides. It will be cos x dx equal to du. So when sine x becomes u, cos x dx becomes du. So the first integral becomes 1 over u squared du. That's right. And the second integral is a standard integral. We can do that without any substitution. So with the substitution, the first integral becomes integral 1 over u squared du. Cos x dx is du plus integral cosecant squared x minus 1 dx. Now all these can be integrated. What is integral of 1 over u squared du? We did this in the last class. Integral 1 over x squared dx is negative 1 over x. Why? Because the derivative of 1 over x with respect to x is negative 1 over x squared. Therefore, integral of 1 over x squared dx is negative 1 over x. Integral 1 over u squared du is negative 1 over u. So that's negative 1 over u. Integral cosecant squared x dx is negative cot x. Because the derivative of cot x is negative cosecant squared x. Integral of cosecant squared dx is negative cot x. Minus integral 1 dx is minus x plus c. So we integrated all these, and what all we need to now do is replace this u with its original quantity. So that will be negative 1 over sine x minus cot x minus x plus c, or negative 1 over sine x is cosecant x. So the result is negative cosecant x minus cot x minus x plus c. So this is the kind of integral you need to spend some time. Now go back and look at this one more time and write this down a couple of times to learn the various steps that we have used in doing this integral. All right? Okay. Let's do another one.